Now let's say we got an equation of a curve. Now the integration is all finding adding up all the slices to find the whole. Now, for example, let's say I got an equation, a curve which is given by f of x. Now, f of x is a function like y. Can be equal to x squared plus 5x plus 7, whatever. So let's say that can be in. And I want to find out the area. To find the area under the curve from this point to that point, I need to break that one into tiny pieces. That's differentiation. And then I just add them up. I find the area of that one, that one, that one, that one. If you have a look, some areas are easy to find. The reason is because they are either rectangle or a square. I can easily find that one. Some areas are difficult to find. For example, this bit area. If that was a triangle, it's easy. This bit area. It's not a triangle, it's a curve. So it's different. So to find that one, what we do is we use a law. There are multiple ways of doing it. A long way is like trapezium rule. Or what you can do is you can draw rectangles with a certain thickness, a certain width. So draw a rectangle. Now, when you draw a rectangle, to find the area, you can find the area you start with. Okay, let me draw there is no rectangle here. So I draw the rectangle. So I can find this area, but I will miss this area. I will find this area, but I will miss this area. I will find this area, but I will just miss that area. I will find this area, but I will just miss that area. So these are the areas that I will miss. The others I can add. So I can get approximate answer. Now, if I want to find out more accurate answer, this width, I can reduce the width and I can have like a smaller rectangle with a smaller width. And that will give me a more precise answer and so on. But this is a long-winded way, it's very long way. We need to actually find a way where we can actually find the exact one, exact area, and easy way, because this will also miss that bit of areas. Yeah, and you can see whatever the area I will get, because I'm missing a lot of bits, so I will have an understated area, understatement. It won't be a proper area, the value will be less. So how do we do that one? For this one, we use an integration. Now, for integration, the operator we use for integration is this. This is the operator we use for integration. The thing that we want to integrate, we just put here in the middle of these things. That's the thing we want to integrate. Integration is completely opposite to differentiation. Okay. Now let's say I got a number, I got equation, and I want to integrate. So let's say I got y equal x squared, and I want to integrate this thing. When I integrate that thing, I need to put this bit on both sides. This is an integral. Yeah, operator for the integral. I apply that on both sides. Now, when I do that one, this side will become like this. This thing, integration, the way we do integration is we write it down, we add the power. Differentiation, we reduce the power. Here we add the 1 to the power. In differentiation, we multiply. Now we divide. Yep. So that will become x cubed over 3. Now then there's another thing that appears. A constant of integration will appear. Now, where does this constant of integration comes from? Now remember, the integration and differentiation, they are vice versa, yeah? So where does this constant come from? The reason this constant comes from is because, let's say, I want to differentiate this thing, not integrate, differentiate. I have, let's say, x squared plus 5. Yeah, sorry, not x squared. Let's do x cubed over 3 plus 5. I want to differentiate it. When I differentiate that one, this thing becomes 3 comes out, x squared over 3, and differentiation of this thing is 0. So which means I got the answer as not 3 and 3 cancel out. I got x squared. So when I differentiate this thing, I got x squared. Now, when I integrate the x square, when I integrate it, it should give me back this bit. Because I said if I differentiate, yeah, it's kind of giving me back x cubed over 3, but it's not giving me back 5. Because I know the differential of a constant is 0, so I need to bring that one back. So, but we don't know it's 5 or 20 or 20.5 or ever. So hence we introduce the coefficient of integration c, and we can find the value of c. There is a way to find the value of c, but at this point we just need to know there is a c that will appear. Okay, so this is basics of integration. Now we will do some rules for integration, and then we will discuss that further. Integration. Okay, let's say if I want to integrate x to the power, sorry, not x to the power. Let's do, rather doing x to the power, let's say I'm integrating something to the power n. That can be x or y or whatever. Because there is an x, so that has to be x. So I put the x in the box. The way it works is, it will become x n plus 1 divided by n plus 1 plus a constant of integration. The constant of integration will appear. Now, if I got integration of a constant, where k is the constant, like the number 5, 7, 8, or 9. Integration of a k will become a kx plus a c. Now then there's a strange case. Now, for example, if I got the x to the power minus 1, integration of x to the power minus 1. Now, if I do that one, if I follow this rule, it should be x to the minus 1 plus 1 divided by minus 1 plus 1 plus a c. So that becomes the x to the 0 over a 0. Now you can't divide anything by 0. So this thing is not possible. This thing is not possible. We do a different way, which we'll talk about in a minute. Okay. So this one we cannot use. That's hence I'm just doing that. Okay. Now, integration of a sine x. Integration of a sine x is a cos x plus c, actually minus cos x. Integration of cos x is a positive sine x plus a c. Integration of is 10x So these are the few rules that you need to know. The main one is the first one, is the main rule. Okay, let's have a look at the first one. Integration of 5x cubed. The 5 already comes out, and you just need to integrate the x cubed dx. When you integrate the x cubed dx, that will become a quantum root. 5 is here. That becomes the x 3 plus 1 divided by 3 plus 1. So that becomes a 5x4 over 4. But you need to add that constant of integration, which is a c in the end. Do not add the constant of integration until the very end, but you can add it until the very end. This one, differential, because when you integrate, when you differentiate the e to the x, it's always e to the x. So differentiation is going to be the same, integration will be the same. Integration of that one is e to the x plus a c. That's it. Now, if it's x to the power 10, that will become x to the 10 plus 1 divided by 10 plus 1. So x 11 over 11 and plus c. Not forget the c. Okay, this bit. Because if you remember, that is x to the minus 1, and you cannot do x to the minus 1 integral. So this is a special case. Always remember, if it's 1 over x, it's ln of the x plus a c, where c is a constant. Okay. Now the last one, differentiation of 4x squared plus cos x. When you got that kind of thing, you need to differentiate this bit and you need to differentiate this bit. So let's differentiate that bit. And then we differentiate this bit. Okay. Now 4 is constant. We can't differentiate the constant, so I'm just going to do that one on this side. 4 is constant, so we cannot integrate the constant. So 4 is out. Now x squared becomes a x cubed over 3 plus different integration of cos x is a sin x. So that thing becomes a 4x cubed over 3 plus a sin x plus a constant of integration.